to spend time learning about things. We have to get to a point where we keep trusting experts again and not trusting the internet, right? So that's one of the things I mentioned, that this information going forward is the information gleaned by scientists in their field. Well, I'm not an expert. I trust that they're an expert because we have a very rigid process for publication to make sure our information is correct. Okay? So if you're not, if you're used to thinking that experts aren't as necessary these days because of the internet, they're actually more necessary because of the proliferation of incorrect things that you get from the internet. So I just wanted to mention that as a starting point to realize that I'm trusting the experts that put this together. I can read some of the peer-reviewed journals, even though I'm not an expert, but I trust them because they are validated through a very time-tested process. Okay? So what does this have to do with the rest of Democracy Days? Obviously, we're talking a lot about disasters and things like that as well. And there was a presentation earlier yesterday on the big disasters. The levees broke. And so we're going to be doing that again and again. A little more reverb in this. There'll be 3 other episodes of that coming forward. In addition, later today, there'll be one on mass casualty events from a nursing perspective, so that ties into it as well. And then disaster response. And something that we'll touch on a little bit today, there's another one later this week called Whose Water Is It Anyway? Has to deal with aquifers and water depletion, and that's something that factors into our complicating factors in disasters. So it fits in well with the rest of the themes of the Democracy Days presentations. So get a little bit of background on what we're going to learn today. The first thing we're going to be talking about is the types of disasters. There's more than one category of disasters. So it's important we realize that different disasters fit into different categories, requiring different responses and different methodologies for study. We'll put the data on past disasters, right? As part of the data on past disasters, we're going to make the most democratic thing of all. We're going to take a poll of the audience, right? You'll all get to be participating. And we'll see how your poll results, we don't have a lot of people here today, but we'll see how your poll results on data compared to the actual data from our region, right? Then we'll have changes affecting possible future disasters. So we have a flood, we have another flood. Is there anything that happened between the floods that could make this next flood more severe, less severe, because of other changes that we have either undertaken or not undertaken? So we'll explore those things as well. Future disaster likelihood, right? A lot of science is predicated on past predicts future, but with the possible changes to some of our environmental concerns and other things going into the equation, there can be changes to the future likelihood based upon the past likelihood. We have to explore the possibility. Scientists always explore possibilities, even if they lead to a conclusion that says, okay, it didn't happen anyway. We have to explore it to see if it is a consequence. And then finally, reasonable precautions to take. We'll talk about reasonable government responses, reasonable community responses, and then reasonable personal responses that you can do to prepare yourself for, as best you can, for response to a disaster. Okay? So first of all, we're going to discuss the types of disasters out there. And the first type of disaster we'll talk about are the one that most everybody is familiar with, and it's the natural type of disaster, right? Natural disasters include floods, earthquakes, wildfires, and tornadoes. A secondary type of disaster is called a technological disaster. This is like when a dam breaks or something that was a result of a technology snafu. Then we have biological disasters. We lived through COVID, right? Bird flu now, in some extent, and things like that. Those are examples of biological disasters. Environmental disasters, oil spills, oil spills, chemical plants, train derailments, things like that that relate to different types of things. And then we have also social disasters, right? Social disasters are predicated on wars, terrorism, social unrest, things like that. Economic disasters are generally the final type we talk about. Some things like the Great Depression or the financial meltdown of the savings and loans that some of us in the audience may be remembering. Most of you are a little too young for that, but you'll see that as well. So this is where your participation comes in, right? We're going to have an unofficial poll of your proximity to these different types of disasters. So again, because we have a small group and some of you are very young and might not have luckily been exposed to any disclosures, I'm broadening the scope of it a little bit to include, were you directly affected by a disaster? Were you indirectly affected? What does it mean by indirectly affected? Did you provide shelter to somebody who was displaced by a disaster? Did you volunteer as part of a disaster relief program, right? Did you have a close friend or a near immediate relative who was affected by the disaster? Okay? So those are the ground rules for your raising hand votings. We will not be recording these for future. We just want to get a general idea of how often. Of course, you can have been affected by more than one of the disasters. So with those ground rules, let's start with natural. By show of hands, how many people have had some involvement with a natural disaster? Raise your hand. 1, 2, 3, 4, 5, 6. Nearly everybody in the audience said that. That's one doing fine. How about personally a technological disaster? One you may have been familiar with locally is the Tom Sauk Reservoir overflow. We'll talk a little bit about that later, but if you don't know what I'm talking about, this was back in 2005. And there was a failure of technology that allowed a reservoir to fail. Okay? Nobody is figuring out those. How about biological? I'm sure everybody's involved with the more recent biological one, COVID of some type, right? Bird flu, things like that. So that's pretty high level up there too. But until very recently, that had been more rare. Okay? How about environmental? Anybody affected by one of spills or a train derailment, or anybody live anyplace else? How about social? Anybody been unfortunately associated with the Terrorism Act or anything like that? A couple people. Okay? And then finally, economic, severe downturns, economic disasters that have really affected you or somebody close to you. So the unofficial poll is by far and away natural. Biological runs a close second because of the COVID and bird flu. And then everything else is pretty much farther back on the list of things, right? So in our unofficial poll here, that's what we found. Okay. So that's, now that we have that, remember how I said that you have to trust experts and who compile data over a long period of time. This is a small sample size over one specific region. It can be valid. It's most likely not completely valid because the sample size is too small. So how can we compare that to what we actually see in our results? Okay. The data on past disasters that I'm referencing is from Missouri's SEMA website. SEMA stands for the State Emergency Management Agency, basically Missouri State's version of the Federal Emergency Management Agency. And they compiled the data with respect to past disasters in our area. Right? And so, if we take a look at this, and I was shown how to do this, I'm going to make sure I get it right. That's not the one. Oh, because it's under. There we go. So you can see here, this is the SEMA's website that the link leads to. And here is the major disaster declarations from 2025, this current year, all the way back to where they kept decent records, including emergency in 1957. Okay? Spoiler alert, it's mostly floods, tornadoes, and severe weather. As a matter of fact, all of them, all of the natural disasters declared in Missouri are severe storms, flooding, one ice storm, right? But again, that's severe weather. So that is the data related to the most likely disasters to occur. So burying the lead right at the start, right? But again, most of you have been involved in one of those, whether it be a tornado, whether it be a more severe weather event, or a flooding event to go along with it. So Missouri collects very good data. This is a very good website. You can look it up. You can see my notes that tie into the links that tie into these. And they do a very good job of tracking the data and giving you more specifics exactly where it's located. So you can see where in the state that was and how widespread it was. Okay? So if we go back then. Okay. Let's go back one slide. Okay. So I'm sure you're all familiar with the big flood here, right? This was the major flood here in the Midwest back in 1993, often referred to as the Great Flood. It was, at the time, called a 500-year flood, right? It overtopped a 200-year levee, which we didn't have a 500-year levee at the time. We do now, right? And as a result, It happened, it started actually in 1992, the fall of 1992, with excessive rainfall that saturated the ground. So as more upriver locations got more rain in the spring, our ground was already saturated, and as a result, we had the flooding that could no longer be dissipated by the natural measures. So this is a view of the normal water basin surrounding St. Louis, and this is what happened during the Great Flood of 1993. Massive intrusion of floodwaters into this. And those of you who are part of it know that locally we had somebody that did some damage to one of the levees to make one of the situations worse. But it would have been very bad even without him. The actual numbers that came in as a result of this was that $15 billion in damage, which, if that were done in today's dollars, would be $33.6 billion worth of damage. There was a more recent flood in 2019, which was another 500-year flood, right? And it was the second highest flooding event in the state since recorded history. So the two recorded flooding events in the state, they both happened within a 26-year time frame within the last 40 years of the state's history. So obviously floods and weather-related phenomenon are the thing that we statistically can show are the most likely things to happen in the Midwest. Not a big surprise there. Recently, I don't have a slide on this. Like I said, I like to do a lot of talking and less visuals. Where the tragedy occurred in Texas with the flooding related to a river that took out a camp, a young children's camp. And so that's in the top of most people's minds today because that was a rapid type of flood. This flood was that thing that you see coming. It's like the train coming down the tracks for a long period of time, and you see it coming, and it just keeps building and keeps building. Other than the dike, when the dike was torn through, it was pretty much just a slow, gradual event that lasted for months, as opposed to that one down there, which was a very short-term, very devastating effect. So floods have very different consequences based upon their severity and the distance, the regions they cover, but they do have some factors that have in common. One of the common factors in most floods disasters that we look at is preparedness, right? Preparedness. Are we building in a floodplain? Are we prepared for quick evacuations? Do we have sirens available? And so those are one of the things we'll be discussing a little bit later when we talk about the things that governments and societies can do to make things better. Okay. Make sure I cover my topic. Okay. So in addition to this, I don't have a slide on this one either. This is where I was going to talk about the Tom Sauk Reservoir, the technological disaster. Down by Johnson Shut-ins, or Elephant Rock State Park area in the southern eastern part of Missouri, there was a Tom Sauk Reservoir. And what happens is when you provide power to the power grid, it's instantaneous. They literally have to provide it now. They run the turbines now that provide you with the electricity. We have very few storage capacities like big batteries, like you have to back up your cell phone to charge your cell phone. We don't have those in the power grid in this part of the country. Very few have them as well. And as a result, what they do is during non-peak times, like at night, they pump water into this reservoir, this man-made reservoir. And so when there's a high demand, when everybody needs air conditioning, electricity is running, they run the turbines from the reservoir that they pumped overnight, and then that water pushes the turbines at high peak times, okay? So that's how a peak demand power plant works. Well, what happened in the Tom Sauk disaster, and we talk about mitigation things, is they knew there was a problem. They went up to inspect it, and 5 weeks before the disaster, water was coming over the top. And the reason was because of the technology. They had a faulty sensor that was not reading the proper level. So the pumps kept pumping, thinking it was filling the reservoir, and it was overfilling the reservoir. So they shut it down. They installed new locations, and they put in a fail-safe measure. Long story short, they messed up the fix, right? They messed up the fix. And as a result, the large disaster happened later. The pumps continued to pump when the sensors were set at too high a level than what they were actually measuring. It said, nope, the water's fine. Wait a minute, the water's overtopping the thing. So that's an example of a recent technological disaster. Thankfully, nobody died. 4 people were seriously injured in the water rushing down. But it's one of those things that can happen not because of design or bad preparation, but simply human error. And so we have to realize there will be some human error involved in this. They spent the money, they put the time in, they just made a mistake in doing it. So when we talk about mitigation and things that we can do to fix things, we always have to realize there will be some human problems with dealing with these situations that we just can't factor out of the equation. Okay. So what are some changes affecting possible future disasters? I've already talked about how in Missouri, floods, tornadoes, things like that. What's happening since our most recent ones, or as a trend, that can be factors that change possible future effects. Obviously, the first one is global warming. We'll talk about global warming in a bit as well. But global warming, this is one of the ones where you have to trust the scientists. Trust the scientists. Global warming is real. It's caused by people, right? That's just the way it is, okay? But that doesn't mean we just ignore it. We say, okay, what can we do to see if global warming creates additional effects, and then what can we do to mitigate any additional effects caused by global warming? And then secondly, in this area, there's one called aquifer depletion, okay? And aquifer depletion, Missouri, primarily the southern half of the state, we'll see on the slide, is a big aquifer, underground water, which makes us very drought resistant. Our farmers can pump from it. You might have a well on your own property that uses aquifer fed water. And as a result, we have this natural source of water. But as we'll see, depletion is occurring because of many different causes. Farming is one of them. But other things can affect the groundswell. So we'll talk about each of these individually. So what are the global warming consequences? Well, you're going to have more frequent events. What happens is we get more energy in the atmosphere. So more energy in the atmosphere due to global warming means not only do we have more frequent events, but when we have them, they're more energetic because you have more energy. I make the example in my class all the time. Imagine you were rolling a ball up a ramp, and it only got halfway up the ramp. Okay. In order to make it go further up the ramp, you'd have to put more energy into it, right? So the more energy you put in, the more you get possibly back out of it in a more confined space. So it's all about making that more likely. And then, of course, the increase of drought likelihood occurs as well. Droughts have been well studied in this country. All of the effects that can cause droughts have been studied, and there is a causal link between global warming and drought increase. Okay? That is as close as we can have to a proven fact from scientists. Right? And then, so what's a little bit about global warming science? I won't bore you with the details too much, but right, in the context of this guy, NOAA, which is the National Oceanic and Atmospheric Administration, runs a website called climate.gov, right? And they have very simple to read in layman's terms, reliable, true information. Okay? A lot of people are saying, what can you trust these days? Well, when an expert validates it and says, yes, that is legit, then you can pretty much trust it, right? So our government is doing a pretty good job still giving us good information on things that are legitimate. And it says right there, you can see this is the U.S.'s website. We know the world is warming because people have been recording daily high temperatures, and the essential truth. And you read through this, it tells you the evidence in a way that the average person can understand that global warming is caused primarily by people, right? So that's information that we use to draw these conclusions relative to global warming. One of the things that science requires of a scientific principle to be valid is for it to make predictions. And so one of the things in the global science prediction we made was the cooling of a higher level of the atmosphere. Again, not to get too sciencey on you, but the Earth has several different layers of the atmosphere. It's not that there's more energy overall. We get our energy from the Earth, from what we put out, and from the sun. That number is not changing. But by putting greenhouse gases in the lower atmosphere, more of it gets stored down here where we live. And as a result, the upper levels of the atmosphere are cooling. That has been demonstrated to be a sign. That's a prediction made by global warming that has been validated. We don't really have more heat, but the heat is stored where we live, and we live with those consequences. higher temperatures are cooler because the heat is trapped down here. Okay? Kind of like if you put a blanket over yourself, your body heat stays trapped close to you. Okay? So there's a little misunderstanding on how global warming affects, oh, sorry, went backwards one slide here. So the global warming sense. Okay, so this is, again, not being too mathy, this is a basic type of curve. Yeah, see all the science people here laughing at this. A standard deviation curve. These are numbers that are called a Bell distribution, which is a distribution of random events based upon a certain occurrences, right? So basically what it happens is you're more likely to have an event in the middle, you're less likely to have an event on the ends, okay? But what happens when you add more energy to the system? When you add more energy to the system, it broadens the envelope and knocks it down. Now, this is not the severity, remind you, this is the occurrence, how often these events occur. So while you have this peaky region here in the standard deviation, 69% of your weather events will happen within this, well, at a certain level of greenhouse gases. Raise that greenhouse gas level, and all of a sudden that guy spreads out. And the ones we're concerned with are these little guys in the tails. Okay, those tails are the extreme weather events. And so when that guy spreads out, those guys get higher. And what that means is you're more likely to have extreme weather events when you get more energy in the system. It's a simple way to explain what happens to this as we add energy to the system. So that's the consequences of global warming related to the science. Okay? So how about aquifer depletion? Aquifer depletion is increasing because of agriculture and human population expansion. Houston is the fastest sinking city. It's called subsidence. As you can see, the settling of the ground, some people call it subsidence, but subsidence, into the voids left behind after water or oil is removed. What are the effects of subsidence? Well, I have the lovely, data page on that. Houston Public Media. Houston is the fastest sinking city in the U.S., right? Houston has an aquifer-based system that they've been pumping water out of for a long time. What rate is Houston sinking at? About 5 millimeters a year. Now, 5 millimeters is not a lot, but over 10 years, that's 2 inches, right? And those of you familiar with the Houston area, Houston is not that high above sea level. So if you sink a few centimeters in as short a time as 10 years, you've got a real issue. Your floods become more severe. They go further inland, things like that. So subsidence is a possibility of aquifer depletion. Now, our aquifers in the Midwest are being depleted as well. Not to the extent they are in the Houston area, thank goodness. Right? It always goes back to slide this one. So, as you can see from this map, we show Missouri's aquifer regions, right? And the biggest one is this one in the files called the Salem Plateau. Almost the entire southern half of the state is this aquifer called the Salem Plateau. And the Salem Plateau is being depleted through agriculture and other reasons, right? As a result, as we'll see later, there's also something very important with this corner of the state that's related to this, known as the Madrid Fault, right? But for now, we're talking about the water depletion. Up there, you can see St. Charles up there. We're part of a different region of Missouri's keeping track of the aquifer regions. And our region, by the separation of this one, and the Salem Plateau, while it does extend all the way up to the Missouri River, it's definitely much more, it's more deep and has more quality down in the lower regions. So while our local area is not as likely to suffer from aquifer depletion, related areas to us are vulnerable to aquifer depletion and the consequences of aquifer depletion. Lowering levels, of course, and voids left behind. I'm sure you've all been familiar with some of the sinkholes that have opened up recently in different locations. Not all sinkholes, but sinkholes can be a consequence of aquifer depletion. If you remove what's supporting the underground structure, the upper structure collapses on top of it. Okay? So this is one of the things we might run into with our with aquifer depletion affecting us. So we've talked about what the current data tells us. We've talked about what changes are occurring that could change the data, right? But we've left one big guy. Wait a second. My slides out of order here. Give me 1 second to check this. Oh, okay, I did it this way. Okay, that's fine. Okay. So, what are those two things going to do to our, by predictions, what are those two things going to do to our likelihood of events? Flooding, tornadoes, and severe storms are still the most likely by far. Those changes are only going to make those more likely and more severe, right? Wildfires are much less likely. We hear a lot about wildfires out in the west of the country primarily, in Canada and things like that. But because of the fact that we have an aquifer-fed system, most of our trees stay green even during droughts for the most part, making it much less likely we have a wildfire. Okay? But what about earthquakes, right? Aren't we on a fault line? Don't we have a New Madrid fault here? Why do earthquakes get no love in the disaster realm, right? Well, it's because, sorry, let me do this, I'll flip back to this one. Okay. This is a map of the St. Louis area's urban earthquake threat ratio, right? Fancy name for something saying, what's the likelihood of having an earthquake effect and how severe will it be? Now, everybody's familiar with the Richter scale, right? The earthquake scale that goes along with that. For those of you that don't know, when you go up one number in that, you actually increase 10 times in intensity. So in going from a 6 to a 7, that's 10 times as powerful. Okay, so it's a little bit of a misnomer. What we physicists like to talk about is the G-forces experience, right? If you've ever been on a roller coaster and ridden a roller coaster, and a typical roller coaster, when it goes over the top and you feel that pull on your body, generally they tap those at about 1 G of force, 1 G of acceleration. You get much more than that and people get sick and have other issues and things like that. Now, fighter pilots, they get many more Gs. But this is the likelihood of different regions based upon the ground configuration of what likelihood in this one. And the data shows, and this was originally done in 2014, but the new study just came out, the chances of a 1 second ground shaking sufficient to cause 1/4 degree G of shaking, which is mild property damage, right, is only 2% in the next 50 years. Is only 2% in the next 50 years. Now, down here in New Madrid, when we go to the next slide and we look down here in New Madrid, Missouri, oh, I'm sorry, I didn't put that slide in, my apologies. New Madrid, Missouri, the probability is much more likely, but New Madrid is down in this lower region. I'll go back 2 slides here real quick. New Madrid, Missouri is down here in this slide, right? So the people down here will have more severe earthquake issues due to aquifer depletion because without the support of the ground, an earthquake hits it, you cause the ground to shake more than it normally would. Okay, but again, that's not quite in our area, so it's a little bit separated from us. We have a little bit of separation from that location, but an area-wide disaster is still going to be felt up here in its consequences, right? We all know that when people needed to rebuild, there's a shortage of building supplies for people who are just building casually or, something like that. So everything is related when you're in the local area, regardless of whether you're actually involved in the earthquake or not. So now let me flip back 1 slide to the one that forward, the slide that I missed, this one here. Okay. So this one was slightly out of order. This is the Mississippi River levels from 1861 to 2022, right? We know we're having higher frequencies. You can see here the big floods, the big levels at the Mississippi River level, right? And so the Mississippi River level, this was at St. Louis, right? And as a result, we did some mitigation effects to try to help our local area. Gumbo Flats, which most people know as Chesterfield Valley, built a 500-year levee, right? And that levee has made that population growth possible in that valley. But what it does, there's always a consequence to everything you do. Now what that does is shove the water downstream, right? And where's downstream? The city of St. Louis. Where's the city of St. Louis? Do they have a chance to build flood walls? No, they're right there on the river, right? So we're more likely to pass those effects down the river because of our effects of this mitigation effects we take here. So when we talk about mitigation effects that we take, we always have to realize there's a cause and effect, there's a consequence to every mitigation we try to do. And the severity of the increasing flood levels shows that generally after every flood, somebody fixes something, which causes and they can't really do anything about it at the city of St. Louis level, because like I said, they'd have to just build big dikes around the river, which they can't do. So the levels there are kind of a bellwether of what all of the effects cumulative are. So that's why we look at those values. And this one goes back 120 years. We got a lot of good data on this one to talk about results. Okay. So, reasonable precautions to take, right? There's a space called ready.gov that deals with precautions that you can personally take. But we're also going to talk about at this time community and government responsibilities. That's why I blended in with that part from the last slide about mitigation effects and things like this. I have a personal story. In 1984, I took a semester off from college to work in New Orleans. There was a World's Fair going on down there, and I spent 6 months down there. And I had a lot of time off, and I traveled around with locals learning about their about the situation down there. And one of the things I noticed when I went through is I noticed the levees. I noticed the pumping equipment in the levees. This is 1984. And they were vastly in disrepair. Right? We're driving around, and I said, my gosh, are all your levees like this? Are all your pumping stations bad? And to one, they said, yeah, it's been an issue for years. We know it's an issue, and we just aren't doing anything about it. Right? Well, of course, we know 20 years later, 2005, what happens, Hurricane Katrina. The levees broke. The pumps were not ready. They still hadn't done anything substantially about it for another 20 years. And so that's one of the reasons it was so devastating. So when we talk about precautions to take, one of the most important precautions we can take is information. Information is relatively free. Building dikes and levees and things like that are expensive. So that isn't always the best manageable solution. We love to throw money at a problem and fix it. Right? But the fact is, New Orleans is below sea level, right? And when you build a location below sea level, flooding is nearly inevitable, even without a storm. So the thing we can do is to do something, is to at least have information. The first thing we can do, that everyone can do, is share the information. Sharing the information, the correct information, not the AI, maybe colored information, right, is important because then we can decide, wow, you've convinced me. This goes back to my earlier talk about respect of experts, right? None of us in this room are qualified to read all the papers and all the science that says we have to trust our experts to some extent on these fields. And then we have to say, okay, what can we manage? There's only so much money, we got to go back and forth to it. But without the information and without people listening to the experts, we're not going to take a useful course of action that will actually help to mitigate or in some cases prevent more severe damage. So that's the first thing, precaution we can take when we talk about being prepared for disasters, is to get the information out there. And I've mentioned several websites in here, and the National Oceanic and Atmospheric, Missouri States, I actually had FEMA in there and a couple of others as well, as you'll see at the end, the U.S. Geological Survey, all these different places, they all have the correct data, the correct scientific data. Now, earthquake predictions are hard to do, but the flooding data we have a lot more stuff on. So when it comes to flooding, our most likely stuff in tornadoes, we have a lot of data to say, this is the likelihood. So if we don't have the money to do with it, what can the information do with us? What's another reasonable precaution to take? Well, one of these guys, right? This is a weather radio endorsed by the NOAA. It's got both shortwave, AM, FM, the good old antenna type here, right? It's got a hand crank generator, right? It's got a battery backup. It's got actual physical batteries you put in it. So it's got 3 different ways to repower your cell phone and to get information. Because during earthquakes and severe disasters, if you've ever noticed, cell phone service goes in the toilet, right? Because everybody's trying to use it. It's not necessarily the towers come down, sometimes they do. It's just that the demand is so high they can't handle all the traffic, right? So you always should have a weather radio available to you to keep you advised in case you lose the power, with a built-in battery backup, and this one even has a solar panel, a small one. It takes a long time to charge it up here at the top. But it has a reading lamp, which uses very low LEDs. I'm not endorsing these. I'm just telling you that this is a very reasonable $30 precaution you can take, and it will charge your cell phone. You can hand crank things to go along with it as well. Obviously, water, right? You don't necessarily have to store food, but you should store water, potable, drinkable water. That's crucial because we can do without food for quite some time, but we can't do without water for very long. And if the pumps go down and you aren't getting pumped water to you, only the water you have. Water is shelf stable, right? So you can keep a jug of water, change it out every month, at least. And the general rule of thumb is 2 gallons per person is enough to keep you going for a week's amount of time. Now, you're not going to take showers in that. You're not going to do severe cooking, right? This is subsistence level water. So have a couple of gallons of water in your house for each person in your house. You can always use it and refill. It doesn't have to be bottled water. It can be tap water and just taken away like that. That's another reasonable precaution. Ready.gov has a lot of these precautions listed with it that you can do individually, okay? The other thing you can do is get some training, right? Get some training. Many of you might have been involved with the disaster because you volunteered to help people out. If you're volunteering and filling sandbags, that's a pretty low training level. You don't have to have a lot of training to follow. But you might want to know first aid, right? First responders can't be everywhere in disasters, so having first aid ability, being able to staunch the flow of blood, disinfect wounds and things like that is a very useful thing. Small consumption of your time that can pay off back as far as that goes. Training on, of course, we all get the earthquake training as kids in severe weather, right? We go under our desks or we go into the basement. We all know that. We have very good preparation for this. In Missouri, we're pretty good. You see the public service messages during storm season all the time. Don't drive through flooded roads, right? They remind you of that all the time. That's one of the ways people die during floods is they go through flooded roads. And so thankfully we haven't had too many issues with that here, even when we've had flooded roads, because it's information. The information gets out there. It's relatively cheap to get the information out there. And then you, of course, preparation, follow the advice. When you get there, you follow the advice. You can't say, okay, he said over the radio, I can afford $30, but then you don't order one. Or, yeah, have a couple of gallons of water around, but you don't do it, right? Because we always think it'll never happen here, but we know it did happen here, right? And it will happen here again eventually. We just don't know when. We can mitigate it by being prepared and not stop it, but we can mitigate the disasters, both personal and community-wide. So and then for personally make a plan. Have a plan. This is part of knowing what you're supposed to do. If you have a fire, we all know our fire exits, right? But if we have a flood and a road gets closed that we use all the time, right? Do we know the alternate roads we can use? If we have to walk out because the roads are blocked, do we know a shorter path? The GPS on your phone is not going to be working in all likelihood, and you'll have to have some familiarity with your local area. Do you know where your local shelter is? If your house gets damaged and the first responders are responding to a lot of other people and you're able to move and leave, do you know where you're going? Do you know where you go in your area to either help other people who are damaged or to go yourself for aid, right? Generally, they factor in churches and schools, but do you know for sure which one is the starting point for you? That information is out there and available for everybody if you're in your emergency preparedness. In St. Charles County has a link in its website for people in St. Charles County as well to help you with that. I didn't put that link in here, but that's one of the things you do. If you don't have a plan, then you're winging it, right? So being prepared by having the materials, having a plan will mitigate the consequences of the disaster as best they can. This is also true. Building the kit, I mentioned the water and the weather radio in the kit. If you go to ready.gov, again, it depends on things. Some people want some of those prepper-type food packs, right? And that's okay. You don't have to have a month's supply, but a couple of days' supply is nice just to carry you through, because the way we normally cook food may not be available. If there's no electricity, most of you use electricity or gas, and if they're not available or unsafe, you won't be able to cook in the traditional manner, so you might have to get by with some shelf-stable alternatives. So, like I said, ready.gov mentions these and others to go along with it. And one thing that's often overlooked is financial preparedness, right? When you have a disaster and you are, most people in this country live paycheck to paycheck, and they don't have a lot of cash around the house. I don't advocate keeping a lot of cash around the house, mind you, especially if you don't have any, but if you don't have access to the bank, right, and the credit card system is not working, right, how are you going to pay for goods and services, right? So a lot of people encourage, ready.gov does recommend keeping some cash around, because that's generally going to be accepted no matter where you go as well. And they also talk about financial preparation as in documents, right? If your house burns down, right, because of a fire, or your house collapses because of an earthquake, and all your documents were in that one location, right? Where's my insurance policy? Where's my birth certificate? Where's all of those things I need? They're at the bottom of the rubble pile, right? This is often a huge problem for people as they go, when they recover from a disaster. That's sometimes one of the hardest things to do, is to say, well, where are your documents? Where are all the things that you need to start fixing the things that were gone? So that financial preparedness is a big deal in terms of records and things like that. And then, are you tech ready, right? I mentioned this weather radio. It uses shortwave radio bands, which as a receiver, you don't need to do but turn around until you get it. The emergency channels are 7 and 14. They have some really simple numbers. So if you do have shortwave will work even when everything else is gone. The U.S. maintains a shortwave database throughout the country. It goes incredibly long distances at very low energy. So if everything else comes down, the shortwave system will still be there to help us communicate. Now, of course, you'll mostly be receiving information, and that can give you things like they have 7 different regions around the country, but at times they can break those regions smaller for local things. So if the entire Missouri had an issue, we're going to be going to different locations, so we wouldn't get the same message. But they would have a scroll going on and saying, those of you in the St. Charles area, these are the locations providing service to you. Those of you in the Franklin County area, these are the locations providing service area. But without having that tech ability ready, you won't be able to get that information. Right. Now, of course, I'm talking worst case scenario here, but if you've talked to anybody who's been in one of these massive things out in the West recently with the wildfires, those situations have arisen for several days where they didn't have cell phone service and other services that we rely on so much, especially clean water and things like that as well. Because we're not isolated in this country, it wasn't as devastating as it happened in some area where you have to go. If you remember the flooding that happened because of the hurricane in the Carolinas last year, right? Some of those areas were very remote. And when the one road in there got closed off, those people had no options. So while that might not be us directly in this area, there are some regions of this county where you are isolated in such a way where there's only one way out. And so you have to be prepared and have all the communication you can possibly keep with you. So that's the tech ready part of it. Okay. Here are some of the references I used in my preparation of my thing today. If you're interested, I can share these with you via email or whatever like that. The U.S. Geological Survey, the National Oceanic, the EPA is in there, Missouri Department of Natural Resources, and SEMA is the State Emergency Management Agency as well as that. So in conclusion, I just want to say, and then I'll take questions, basically, it's severe weather, no big surprise there. Earthquakes to a much lesser extent, wildfires to a much lesser extent. But we've seen biological and technological as far as that Tom Sauk Reservoir, right? We have seen those that are possibilities as well in a more limited, the technology ones are generally in a more limited basis local area. But that doesn't mean it can't happen here. Okay? So thank you all for your time today, and I'll take any questions you may have. Everybody disastered out? We do have an upcoming 11:30. We have the talk on the emergency response from the nursing perspective. So if anybody's interested, that starts at 11:30. Yeah. Mm-hmm. That's the one I was talking about, yes. Mm-hmm. Mm-hmm. Right. Mm-hmm. It's a complicated question, and it's one that's one of the things where we have to talk about information. Having that information, it's like some people will not get informed about even their own situation to some extent. Do I have earthquake insurance on my house? I don't know. I looked it up. I don't. Right? I didn't know until I did this, right? So I don't have earthquake insurance on my house. Well, that's interesting to know, right? I don't think I need it. You know, I'm fine with it without having it there. But if I make that decision and my life goes into the crapper, what role does government and society have in helping me get back on my feet? That's a big picture question, isn't it? But the whole point of my discussion is why, while I can't be able to answer that, what I can tell you is, if you're more prepared to mitigate your specific situation, then whatever response we can muster from a local, state, or federal one won't have to go as far, because your part of it is not as severe as it would have been if you hadn't been prepared. So, much bigger question than I would have time to answer here. It's a great question. But by being prepared, that's why I think that we can do our part to help everybody else out. So. Anybody else have one? We got 2 minutes. Yes. Oh, okay. I don't like the idea of hydrogen fuel vehicles. I like hydrogen fuel overall, but hydrogen fuel vehicles, while are economical, you run into the issues of the combustibility and the severe consequences if something goes wrong with it, right? So, could. Oh, it definitely could. But it definitely could. But the other problem is then you're basically driving around with a bomb all the time. Right. But if you drive around with hydrogen, you're driving around with a bomb, basically, right? If you drive around with an electric car, you're not really driving around with that. So that's the biggest issue I have with it. It makes scientifically, in a perfect world, a great idea. But hydrogen, big pile of hydrogen rolling around with you. I used to put up weather balloons with hydrogen, and we were very cautious because hydrogen weather balloons will go up higher and faster than helium weather balloons. And so you had to be very cautious when you put up these hydrogen weather balloons to go up into the atmosphere, because of course you would be in serious trouble if a spark got anywhere near it. So. Okay, well, thank you all very much. Enjoy the rest of Democracy Day this week. Yeah, all the Thank you. Thanks for coming.